This is Prince Amebo, and these are my responses to this week's interview questions. The first question says, how would I use a linked list internally to implement a stack? And then the second question says, how would I use a linked list internally to implement a queue? So the first one, how to use a linked list internally to implement a stack. We know a stack follows the principle of the last in, first out, and the most efficient way to implement a stack using a linked list is to treat the head of the linked list as the top of the stack. Why use the head? Because inserting and removing from the head of the linked list both takes constant time, and to push or add an item to our stack, we first create a node and then insert it at the head of the linked list and then update the head pointer. So when we do this, this adds an item to the stack. Why does it work? It works because the newest element becomes the top of the stack, and the time complexity here is 0, 1, and there are no traversals. Also, to pop or remove an item from the list, we first remove the head node of the linked list and then update the head pointer to the next node. And why does this also work? The head always represents the top of the stack, so when we remove that head, and it helps in the implementation, and then the time complexity here it's also 0, 1. And then how to get the top or the peak of our list, we return a value stored in the head node, and when we do this we do not remove it. And also, to empty our list, we first check if the head pointer is null. If the head pointer is null, then our implementation goes through, and the time complexity here is also 0, 1. The second question asks, how do I use a linked list to internally implement a queue? And unlike the stack, a queue operates on the principle of first in, first out. And to efficiently implement a queue, we use both the head and tail of the linked list. Here, the head becomes the front of the queue, and then the tail becomes the back of the queue. So to enqueue or add an item to our queue, how does it work? We first create a new node, and then we insert it at the tail of the linked list and then update the tail pointer. When we do this, the implementation works. Why does the implementation works? It works because new elements join the back of the line, and the time complexity is also 0, 1. To dequeue or remove an item from our queue, we first remove the head node, and after removing the head node, we then update the head pointer. After updating the head pointer, our implementation works. Why does it work? It works because the oldest element is always at the front of our list, and the time complexity is also 1. So to also empty our list, we check if the head pointer is null or if our size equals 0. If it is null or the size equals 0, then our emptying of the list also implements very well, and then the time complexity is also 1. So in summary, using both head and tail ensures that we are able to enqueue and dequeue in constant time, and this is very optimal for our queue behavior. So these are my response to this week's interview questions. Thank you.